Oh no, I lost the display. Oh, I see, it's good. Okay. Okay, so I have a little bit of a cold, so if I start to get quiet, I'm happy to be yelled at. As Teeny mentioned, I'm a research associate at Stanford. For those of you who are wondering, being a research associate or postdoc is the best job you can have. After that, it's all downhill. And all the faculty will laugh, and the rest of you will find out later. Yeah, you'll see. Okay, so most of the time I spend doing functional neuroimaging of high-level vision, but I have this kind of side passion in synesthesia, which has persisted since I was an undergraduate. And in fact, it was some of the early stuff that Ramachandran did with synesthesia that convinced me to make my way over from English literature into doing whatever it is we do here. And just while I have your attention, I just want to mention my collaborators. John Winnower is now a professor at NYU. Maybe he gave a talk here a few years ago, I don't know. But he's a lovely guy, and he's been doing this with me since we were both graduate students together. More recently, we've been working with David Eagleman, who some of you may know because he likes to do things like write New York Times bestsellers. He's one of these like public intellectual types who has like this insane, relentless energy that you cannot match. But he's also a very nice guy. He's done this nice thing for us, which is collect this very large database of synesthetes, which he collaborates with us in analyzing. And then lastly, I don't think I have time to get to this part, but just in case I do, is my friend Dan Yarlett. He was a graduate student at Stanford with Michael Ramscar, so he did kind of corpus analysis and linguistics and stuff, and he's our computational guy because the rest of us are only so-so at math. Okay. So what I'm going to do, I heard this is kind of a mixed audience. Some people are philosophers, some people are computer scientists and stuff, so I don't know if everyone's familiar with synesthesia. So I'm just going to lay this out. First I'm going to tell you what Grapheme-Color Synesthesia is. And then I'm going to just show you how we measure this in people and how we verify that they are in fact a synesthete. And then I'm going to try and answer some questions about synesthesia, which you don't even have yet, but which you will have after I talk for a little bit. And the main question I'm going to try to answer is, where do the colors in color grapheme synesthesia come from, and can they be learned? And then I'm going to try and tell you that, well, if they could be learned, how could color grapheme synesthesia be perceptual, which is another question you don't have yet, but will. And then even if this happens sometime, how often does this happen? Okay, so that's kind of also, it seems like I'm rambling sometimes, I do have a plan. Okay, so Grapheme-Color Synesthesia, for those who don't know, it's this kind of interesting trait that some people have where when they read text, so regular black and white text on a page, they have this extra experience of color that's associated with the text. So for example, many Grapheme-Color synesthetes will say that when they read an A, that they see red, that the A looks red. And there are a couple of interesting features of this. One is that it's unidirectional. So reading text produces colors, but thinking about or seeing colors doesn't make you think about text. It only goes the one way. The second thing is that the color that they see is a very specific color. So it's not just the label red, but they have a very fixed idea about exactly what color it is they'll see. And I'll show you how we measure that in a little bit so you can see just how specific they are about it. And then this is kind of a very important detail, is that it is a fixed and automatic associate of a particular stimulus. And so by that I mean when they read text, they don't try to recall that there's a color associated with the text, it just happens. And this is another thing, I'll give you some examples of this so you can understand it, but these are kind of the defining features of color grapheme. Okay, so what does it mean to see a color? There's a hard thing you can ask a synesthete to describe it to you. A very small number, and this is kind of really captures the public attention, but it's really probably less than 10% of the synesthetes total, will say that they see colors out in the world. So that if an A is red, the red is out on the surface of the letter, and it's part of the visual scene. And these people are fun to study because you can start doing experiments where you modulate the context in which the color appears, and then try to see where in the visual hierarchy it arises. But it's mostly not that. More often you'll get a description like this, which is that they see it in the mind's eye. Okay, so where is the mind's eye? The mind's eye is a screen which is like maybe inside the head or somewhere other place that they have difficulty describing. Anne was trying to describe to you where the mind's eye was earlier, so you can ask her. I have this quote from well-known vision scientist. His name is Christopher Tyler. He's a vision researcher at Smith Kettlewell. He is most famous, as far as I know, for inventing the auto stereogram, so those magic eye posters. Along with that, he is also a synesthete. And I put up this description he had because I think it captures a lot of things that are true about synesthetes in general. And I just want to refer back to it as someone's kind of subjective description of what they're experiencing. He says, so he has color number synesthesia. And he says that the associations are quite explicit, consistent, and stable. And he says, when I see the number 3, for example, I imagine the Arabic digit projected in a dark space with an explicit golden yellow color spread around it as though projected by a spotlight. And the thing I want to highlight is, the kind of like incredible specificity of detail with which he describes his experience. This is like a very common kind of thing. There can be more or less of this detail. But the idea that there are these very kind of fixed notions about what's happening is pretty common. And then there's a third kind, and this is a description I've got, although not everyone will agree with it, of synesthete who will say, well, I don't really see the color anywhere. I just know what color it's supposed to be. And the analogy that they'll give is that if I showed you a photograph of like an orange or a number 2 pencil, you would say, I immediately know what color that's supposed to be. And if you asked someone to color it in, they could do it for you. But they don't see the color anywhere. They just have a very specific knowledge about what the color is. Good? You guys look like you're following? Okay, great. Okay. And so there are lots of other kinds of synesthesia. So we have graphemes in colors, there are musical notes in colors, there are spoken words in colors, there are numerical sequences and spatial arrangements, like dates that go in ovals. And there are also things like words and taste. And the reason that I mention this, even though I'm only going to talk about color grapheme synesthesia, is that first of all, the vast majority of synesthesias are grapheme-color synesthesia, as far as anybody knows. So mostly it's more than 80% of the people. And then of the rest of kinds of synesthesias that there are, almost all of them involve mapping some kind of learned cultural sequence onto something like a color. And then you do have these other occasional types, which are words and tastes, which are kind of oddballs, but there are very, very few of those kind of subjects. They're very hard to find. Okay. And then before I get into the data part, I just like to throw this quote up there. There's 2 reasons. One is that people have been studying synesthesia for a long time, since the 19th century. And this is a picture of Francis Galton, who I'm sure many of you are familiar with. He's a very fascinating guy. He was a eugenicist. I think he did things like put beans in skulls, and he also measured correlation and why poor people are poor. But he also had an interest in synesthesia. And he has this nice sentence in the very first paper which describes synesthesia in the English language, in which he says that he wants to warn people against the too frequent tendency to assume that the minds of every other sane and healthy person must be like one's own, right? And the idea is to guard against the notion that other people could be having these experiences that you're not having, so therefore they're crazy or they're making it up. And there are 2 ways that I want to kind of reflect on this comment. One is to put it in its historical context, which is that at the time, people had recently discovered that color blindness existed, that it was a thing. And what that meant is that for thousands of years, people went around, like a very significant minority of the population, went around totally unable to see some colors, and nobody noticed when they were talking to them that there was some kind of problem. And so it is very impressive how different other people's experiences can be from yours, and it kind of just slips by. The second way that I want to think about it is from the perspective of the synesthete. And the reason that I want to think about that is that for synesthetes, they often don't realize that their experiences are not similar to other people's experiences until they're teenagers. So you can have a person who's walking around and thinks that all the text is colored, and they think everybody else also thinks that the text is colored, and that they think it's the same colors as them, or in some cases, maybe just that it's also colored. And they often only find out when they get into an argument with someone about what color B is, and then that person claims not to know what the hell they're talking about. And so then they just stop talking about it because they realize they've got some kind of weird thing. Or they will encounter synesthesia on the internet and then realize that other people don't have it, okay? So that's both interesting kind of as like a commentary on how different we can be and communicate with one another, but it's also interesting to me when I try to think about how they evaluate what the source of the synesthesia is, and whether it is a property of something in the world or something that's generated by their mind. And this is kind of like a tricky question because they are both aware, for example, when they look text, that the text has an actual color as black. And they're aware that it has this extra property, which seems to belong to the thing in the world, but also seems to come from them. And this will be kind of like a recurring theme. So I just want to kind of plant that seed out there. Okay. All right, so how do we tell if someone's a synesthete? Someone comes in and says they have this crazy ability. So we usually do these 3 kinds of things. So really only the first 2 matter. The first is that we want to know that it's fixed over time, that they always make the same or always have the same synesthetic response to a given stimulus. And the second is that we want to know that it's automatically generated. And then third, this is kind of an obsession in the field for a little while. We like to show that it's perceptual when we can, because people are kind of worried that people dismiss the field as just kind of associative memory. And I'm going to be making an associative memory, but it's not just like just remembering that A is red. Like I told you that A was red, come back later, tell me A was red. Okay? All right, so the way we do the consistency, I'm just going to show you an example, is we might bring someone in and we ask them to do a color match in a letter. So we give them this kind of thing where they can adjust the color and the lightness of a letter, and then when they like the match, they just click match, and then they go on, they do all the letters for us. And sometimes they won't do all the matches, and there are a couple reasons this can happen. One reason is that not all letters always have colors. And a second reason is that for some synesthetes, the colors themselves or what they see have other kinds of properties that are not color, like surface material properties, like they're shiny or they're textured, and there are things that are, for us, that are hard to generate parametrically. And so they'll kind of complain about this task, and they'll sit there for about an hour trying to do this, and then they'll tell us that they can't, and then we don't hear from them anymore. Because they hate the task, they say it's impossible. But for some people it's pretty easy. So here's a person that takes them about 15 minutes to do each one of these. They did these about 3 weeks apart. And if you just compare the top and bottom by eye, you can see that they get very similar matches both times. They do this quite quickly. And we can put a number on this, although I'm not going to show you a null distribution, by doing something like thinking about the different components of the color space. And so here I just want you to focus on the lower left for you guys and see that the correlation in hue between those two matches, which are done at 3 weeks apart, is about 0.96. Okay, so this is probably the best psychophysical measurement I'm ever going to get. I'm not going to get data like this ever again. Okay, so very, very specific about what the color matching is. And if you ask people to do this, like if you say, all right, bring some controls in who aren't synesthetes, ask them to pick a color for each letter, and then tell them to come back in 3 weeks and do this same thing, they cannot do this. This is like a very non-trivial task. Okay. So then how do we test if it's automatic? How many people here know what the Stroop task is? Whoa. How many people don't know what the Stroop task is? No, I can't tell. Everyone knows what the Stroop task is. Okay, I'm going to make you do it anyway, so that you can remember why something is automatic. Because all we do with synesthetes is we do the Stroop task. Okay, so everybody knows that your job is to say the color of the word that I put on the screen and say it as fast as possible. All right, are you guys ready? Okay. Oh, someone's got to be the bold one. Aren't you in charge? You're the one. Okay. All right, faster.
Yellow, blue, green.
Awesome. Okay, so now comes the hard part. Ready?
Orange.
Yeah. That was pretty good. Why you said orange? I've been practicing this slide. I still say blue every time it comes up. Okay.
Yellow, blue.
I heard someone say red.
Green. Red.
Okay. So obviously the index. So what's going on here, right? You guys all know that you can't help but read the word, right? And in order to say the color that the word is printed in, you have to kind of suppress that automatic reflex. And the way that we measure that, the way that we index it, is that it takes you longer because you have the competing responses and that you make more mistakes, okay? And then we just do this exact same thing with synesthetes. So we give them, for example, for this person for whom A generates a perception of red, we give them sometimes an A that's in red, and sometimes we give them an A that's in a different color that's in blue, or we'll give them this symbol which doesn't elicit any synesthesia at all. We'll ask them in each case just to name the color. And the idea is that in the inconsistent condition, they have two competing things going on at the same time, so they should be slower. Okay, so we have these two kind of measurements, and then when we look at the data, this is just from a particular subject, we see that they are indeed much slower in the inconsistent condition. Okay, so this is like psychophysically, we bring people in, the two things that we always measure are the reliability of their matches and the automaticity of the responses in some way that's like this. How am I doing for time? When am I supposed to be done, 3:55?
Yeah, or 4. 4 is okay.
Okay. All right, this is amusing. I'll try and do this. Okay, so sometimes for some small subset of synesthetes who see their colors as being projected onto the surfaces out in the world. So these people are sometimes referred to projectors. There's kind of a semantic debate about it in the field, whether it's a good idea or not. But back when we started, it was kind of a craze to show that their colors interacted with the real world in the same way. And for a particular reason, we were particularly concerned that we really proved that this person is a synesthete. And so the idea we had was to use this illusion that Ted Adelson, who's at MIT, came up with had made, how many people have seen this before, checker shadow illusion? Okay. Oh, that's good. So even when I butcher the explanation, most people in the room will understand it. That's awesome. Okay, so the idea here is that both squares that are indicated by the arrows are exactly the same color, okay? And just to prove it to you, do this. Okay, so they're the same color. So why do they look different to you? And the kind of reasoning that people came up with is that what your visual system is trying to do, it's not interested in how much light is coming off those squares, it's interested in how much light they reflect. But the problem is that the amount of light that they reflect is confounded by how much light is hitting them. And so you kind of have to pick apart how much illumination is striking a surface in order to be able to see its reflectance. And so given that the lighter square is in the shadow, the idea is that since it gives off as much light as the square that is directly lit, it must in fact have more reflectance. And so your visual system kind of works this out. You look particularly skeptical of that explanation. Okay. But this was the explanation at the time. And so we had this kind of idea that what we would do is we'd embed letters in these squares. And we'd say, okay, we put a letter in the square and we do the same color matching task we did before. And what we want to know is does the illusion, does the context of the visual scene in which the color is embedded change her adjustment of what the synesthetic color looks like? And the prediction would be that stuff that's in here would appear brighter than stuff that's out there. And then when we did this experiment, we did it both with regular colors and with letters. So here's a measurement with controls. Here's her doing it with real colors with squares, and then this is her doing it with her letters, right? So the idea is that this was supposed to be kind of evidence that her color were actually integrated in the visual scene in some sensible ways, that they were affected by other elements of the scene. Okay. This is not the most important experiment, but I think it's kind of fun. Okay, so those are some things you can do with synesthetes. Okay, so question is, where do these colors come from? And there are a lot of ideas about where they come from. And I am not going to be able to do justice to any of the ideas except for the learning hypothesis unless I just give a whole talk about that. But just to give you a sense for some of the things that people think, one idea is that infants and mammals generally, that your brain starts out over-connected. Okay, so this is kind of a neural hypothesis. And that the sensory, so audition and vision have connections which they won't have later in life. So you have this kind of hyper-connectivity. And then over time, as a function of experience, the fact that most of your experiences in vision and audition are not correlated with one another differentiates these sensory modalities. But for some reason, some genetic reason in synesthetes, this fails to happen, and so they end up having these extra related perceptions. I don't think that this is the right explanation, but it is an idea that's out there. A second idea is that what's going on in synesthesia is that you have some kind of innate alignments between sensory dimensions. And so as an example, let me just show you, this is a figure from a paper. If you ask people, if you give them a task where you play them a pitch, like a high pitch, and then you ask them, you present them with a dark square and a light square, and you say, which square goes with that pitch? People will pick the lighter of the two squares. And so there's some kind of notion that people have that higher pitches go with lighter things. And then the question is that given that those are different sensory modalities, how do they know that? Now you can think of a lot of different ways. One might be the intensity of the neural coding, like how fast can the neurons fire in response to stimulus, but there's some way in which those kind of events that come from through different senses can be compared to one another and arranged, and this is a thing that people reliably do across cultures. What's interesting is that if you look at synesthetes, for example, who have pitch color hearing, so when they hear pitches, they see colors, they also show this pattern in their data. And so people who like to think about it this way, what they're thinking is that synesthesia is like cross-modal matching behavior that you see in many people, except it has these interesting differences, one of which is, first of all, that they're consciously aware of it. So that it's explicitly coded, whereas in most people, you wouldn't be aware of it unless I asked you a question. It's something that you can measure, but which people don't experience. And then second, that their relationship between the pitches and the colors is fixed rather than a relative matching, which is the kind of thing you see in those controls. Okay, so that's just to set the background. And then his third idea was actually the first idea that anybody had, which is that back in the 1890s, both Francis Galton and then this other psychologist, Merced, had the idea that the way people got synesthetic associations for graphemes and colors was that they learned them from things that were in their childhood environment, that they learned them from toys or books or that kind of thing. Do people know who Merced is? She's actually a really interesting person. She's the first female president of the APA. When she applied to graduate school at Harvard, they would not admit her because she was a woman. And so what they did is she got some kind of special dispensation to take classes at Harvard with like William James. And then when she would go to the class, all the guys didn't like it, so they would leave, and she would have the class by herself. And she didn't care. She thought that was great. And then after she graduated, Harvard wouldn't give her a PhD. And none of this is the part I like. I just like the end part, which is that several years after that, Wellesley offered her a PhD because she had completed all this work at Harvard, and she told him she didn't want it, which I think is great. Okay, anyway, so a little history of psychology for you. So they both had this idea that there's stuff in your environment, kids pick up this stuff like while they're learning. There's something about learning to read, something about having these color stimuli, and something about some subset of people that's a little bit different, and they develop these kind of associations. Okay. It seems like a reasonable theory, except that there is absolutely no evidence for it. When I first started doing this, back around like 2001, 2002, when I first started looking at it. And by no evidence, I mean like over the course of 100 years, nobody could find a color grapheme synesthete whose colors could be traced back to something that they owned in childhood. It was basically, there's no examples. And so that's not good for a theory. It's not a killer, because it doesn't disprove it, but it's not good. And the second thing was that a group in Australia, the Anita Rich was the first author on this paper, went out and actually just tried to find people like this. So they sent out, this is before there's like mass use of the internet, I guess, by the time they published it. They put an ad in a newspaper, and then they got all the synesthetes they could find, and then they got all the color matches through mail, so people filled out these forms. And then they went to all the libraries they could find and found all the kids' books, every possible thing, and then they put those two things together and basically found nothing. So no matches between what synesthetes were doing and the kind of stuff that seemed to be available in the environment. So they wrote a paper saying, look, there's some regularities in the synesthetic matching behavior, but we can't find anything that points to learning. Okay. And so people at the time were kind of against it. Simon Baron-Cohen, who I think has come around on this at the time, said that if you had this kind of learning, it was called pseudo-synesthesia. Ramachandran and Ed Hubbard said synesthesia is not just remembering a childhood magnet set you played with. And then, this is kind of cheap, but I took a comment off the internet because I liked it so much. And this guy said, oh, it's common for letter color synesthetes to think they've picked up the colors from the colored alphabet above Blackboard and Kitchen, their building blocks, etc. If you ask me, that theory is a worthless pile of bollocks, from which I inferred he's British. Okay, so this is a polemical, how many people in here are graduate students? Somebody thought it'd be good if I said, oh, a lot of you, okay. This is my scientific career, or this is my perception of other scientific careers. Let's start with that. People have a hypothesis. They go out, they collect the data in their thing, they do a test that's significant, they write a paper about it. That happens to me incredibly rarely. What mostly happens to me is that I have a hypothesis, I start making some measurements, and my idea is crazy. But because I'm collecting data, and because I'm learning about the area, I notice something else that's interesting in the data, but which is real, and then I start following that thing. And then when I get the results from that at the end, I go back and write at the beginning of the paper, my hypothesis was blah, blah, blah. Okay. I don't know what everybody else is doing. Everybody else might be awesome at science, and I like kind of suck at it or something, but that's how it's working for me. Okay, and I want to say that because when I started doing synesthesia research, I did not have the idea that I was going to go out and study this learning kind of thing. It's just an accident. But I did know that it was interesting, and so I just followed it. Okay, so I showed you this data before. I don't know if you noticed it. It took me 4 or 5 months to notice this about this data, but there is an interesting repeating pattern in the colors of these matches. And one day we made a figure that looked like this, John and I, and we were like, oh, that's really weird. So we called the girl in who did this, and I said, oh, you have this really weird pattern in your data, can you tell me why? And she said, yeah, I learned it from a bunch of refrigerator magnets I had when I was a kid. And I said, oh my God, why didn't you tell me that? That's like the most important thing that you could tell me. And she's like, I didn't think anybody cared. Isn't this how everybody learns their synesthesia? So I got very excited, and I had her email her parents, and her parents sent her the toy. And now I own several copies of this toy, so there's a photograph here at the bottom, and then we kind of put the colors. Anyway, you can see that there's this very strong correspondence between the two. And so we published like a little paper about it in a special issue on synesthesia saying that it was possible. And then this is going to be a second kind of polemical point, and then I'll try and stop doing this, which is that one of the reactions that we got was that, and I think fairly, especially for a field like synesthesia, where there are many individual case studies, is that you don't really want to have a field which is composed of bringing in like a random individual and then doing one random test on that, and everybody else does something different. And so there's not much value to these kind of case studies. But I do want to say that once we put this case study out there, that's how we got all the rest of the data. And then, there is some value, like maybe you won't figure it out, or maybe it won't become important in the context of the theory until later, but this did turn out to be important just as a stepping stone for other things. And those other things were, don't bother to read all this text. It's an interesting story. Or maybe it's more interesting than what I'm saying, I don't know. One of the things that happened is that we started to find other synesthetes who had also learned their colors from this exact same set of magnets. So we run it, so I was giving a poster at VSS actually, and so a vision scientist came up to me and they said, I am a synesthete, I had those magnets, I have exactly those same colors. And then we found people in news groups, and some people read the paper and emailed us, so then we were able to start collecting data from more people. And this took us several years. This person in particular I found on a synesthesia news group, he apparently used to do this yearly post on the synesthesia group, so people hated the learning idea, particularly synesthetes themselves do not like the idea of learning because they thought it kind of belittled the notion of synesthesia. And he would say, look, when I was in college, I had a roommate, and I said to my roommate said that he could guess all my synesthetic colors, and I said, that's impossible. And people thought it was impossible because the idea about synesthetic color matching was that it is incredibly idiosyncratic. That is like the most commonly paired word with color graphing synesthesia is idiosyncratic. And then this guy started guessing all his colors, and then it turned out that they both had this magnet set. Right, so now there's 2 of them, and then we had 3, and then after a while we had 11. And so this is data that we got off of David Eagleman's website. He has this website where people can go if they're synesthetes and they do these color matching tasks and you can repeat do them. They can have you signed on as a researcher and then you can collect their data. And so this, just as an example from this group, is showing the correlation in hue on the y-axis, and the x-axis is in years, right? And so basically what I'm showing you is that some of these subjects have correlations that are approaching 1 after 4 and 8 years of time. So this is like incredibly specific matching behavior. And the thing is that not only is this very specific, but I think this is like done over the internet. I don't know what monitors they're using. I don't know what the colors look like on their monitors. We just put it all into sRGB. They might see anything at all. Probably not anything at all, but there's some variability that's coming from that which we're not capturing. Okay. And then if we look at those people's color matching data, so on the left here, this is just kind of idealized version of what the magnet set looks like, and then these 11 people are organized with respect to that. Okay, and so you can see, I assume that that's just convincing to look at, right? Yeah, okay. Okay, so what does this mean? So is synesthesia learned? And the way we came at it is we said, well, look, learning can certainly influence the particular matchings that you see. But we don't think that the magnet set makes people synesthetes. So my friend Roland told me that I should write an editorial for the New York Times that said that Fisher-Price was destroying kids. I don't believe it. By the way, I've also tried to contact Fisher-Price about this magnet set because I know a lot more about it than I should. And they wouldn't talk to me. But my friend Patrick, okay, so here's a question that comes up, but you guys haven't asked it, but I'm going to answer it anyway because I know the answer. So one thing that this goes 2 ways. People see this and they say, if I say, what if the person who made the magnet set was a synesthete? People say, that's stupid. But if I don't say that, people go, what if the person who made the magnet set was a synesthete? So I don't know what to do. The answer to that question is the person who made the magnet set was not a synesthete. My friend tracked this guy down who was like on the team that designed these magnets. And it turns out that this color choice is like the outgrowth of like maximizing like the number of colors versus how much it would cost to make the letters. It's like some kind of like economic industrial decision at Fisher-Price. So there's nothing, even though I would love there to be a story in here, there isn't one except that, yeah.
Do you think that the regularity in colors on the letters themselves helped at all in terms of reinforcing the learning?
Yeah, so I think that's an excellent point. So in line with this, so it's true that I don't think it makes people into synesthetes. So I think if you have that letters that there's something different about synesthetes, there's something genetically different about them that makes them have these experiences. But it might be that not everyone who could be a synesthete becomes one. And it might be that if you're given like a particularly nice stimulus like this one, that it helps bring what is kind of like a latent or like a possible thing for you into happening, and that certainly seems possible to me. But I don't really know the answer. Okay. So we thought this was really cool, but I think, for people who've been working in this field for a long time, this was a less than satisfactory as an explanation or something about synesthesia. And I think they had several good reasons for saying that. Like, I don't feel insulted by this. This is kind of a long, so when we published this paper, I put this here because it kind of made me sad at the time, but now I think it's totally accurate. Because it was like the first paper I published, which is that we published a paper in a special issue of synesthesia, and then, so there are all these papers on synesthesia, and then there's an editor. And the editor writes a first paper at the beginning, which says all of the interesting things that are in the paper in the special issue. But about our paper, he wrote this little thing about why our paper was both wrong and probably not that important. And I was like, oh, come on, I thought you were supposed to, like, I didn't understand, I thought the system worked different than it does. But he's right, this is totally accurate. So I'm gonna try and seriously answer these questions. So, the first thing he says is that accounts based on associative learning, like trying to explain synesthesia as just associative learning, are not going to work. And I 100% agree with that. If you put a baby in a room and just give them colored magnets and let them look at it all day, I don't think they're going to develop synesthesia. I don't think that that's what it is. I think there's something different about them, and the stimulus that are around them, they build these associations off of what's in their environment. So I'm just going to punt on this. Why do some people become synesthetes? Because no one has the explanation. Everyone just kind of says genetics. And there are some people who work on the genetics, and I don't know anything about genetics, and so I can't even evaluate what they're saying beyond the fact that it seems to run in families. Okay, but these other 2 points are worth taking up, and there's so many words here I don't even know where they are. One is, if it is learning, and we think that synesthesia is a perceptual phenomenon, how can something that's learned be perceptual? So that's one question. And then the second question is even if you found it in 1 people or 11 people, it seems like most people don't learn their synesthesia. So who cares anyway if mostly synesthetes don't learn their correspondence? And so those are the 2 questions I'm going to try to answer in the remaining amount of time. I'm not going to do that. Okay, so that's what this is here. Okay. And I'm going to answer these in 2 different ways. I'm going to answer the first one by appealing to your intuitions, and then, which is not really science, but I'm just going to do it anyway. It's going to be bad philosophy. And then the second is going to be data. So the second you can leave it. The first one I just tried to go along for a while. Okay, how can something learn be perceptual? Is there anyone in the room who does not experience auditory imagery when they read? Oh, I'm always hoping to find someone. Some people don't. Okay, so before I said that when a synesthete is presented with the letter A, that they experience an extra thing that's not in the A in response to it, which is the color red. But I imagine that most of you, when you see the letter A, or you read a word, that you actually hear the sound of A being said inside of your head. Yeah, everyone has that kind of experience when you read text. You're like, there's a little voice going on inside your head. And that voice is not amodal, it's definitely auditory, right? It's auditory information. And everyone's gone that far. Okay, that's what I think synesthesia is. That's like halfway there, right? It has all the right features. It's something that you learned. It has a perceptual modality. It's automatically elicited by the stimulus. It's meeting a lot of the criteria. What it's not is super specific, right? If I asked you what your internal voice sounds like, I don't know if any of you could tell me. I know that I can't. And I know that the more that I try to think about what my internal voice sounds like, the more it kind of evades my ability to describe it. And I would just want to compare that, go back to this quote from Christopher Tyler, where he said, look, I have these incredibly specific experiences, right? They're incredibly specific. All right. And so this is my first example. So you would be a synesthete. How many people have seen Dr. Strangelove? Oh, that's good. Okay, so if every time you read A, like Peter Sellers in like the Dr. Strangelove voice whispered A into your ear from like 6 inches away, and that happened every single time you looked at the letter A, that would be synesthesia. Mostly that's not happening to us. Okay, so that's my one, the most, I don't know, maybe it's happening to some of us. You guys look happy about it. You're like, yes, that's finally someone. Okay. I thought it was crazy. Okay, so this is going to be my second example. This is the one I like even more. So you can't do this intuition. You can only get like part of the way there with this. You can't really have a synesthetic experience with this. You can just kind of get an intuition for like what it's like. Okay, this is my second one. Okay, who watches Futurama? Yes. I was so afraid that I would pick one that nobody knew what it was. Who knows the read this in my voice meme? Who knows what that is? Okay, so there's some people back there. Okay. You look brave. You look very brave. Okay. The rest of you, so who has never seen this before? Just give me one person like that. Okay, like you. So when you read this, what happens? What happens? Nothing. Or like you read it in your own voice. You can tell me.
Me?
Yeah.
Yeah, I guess I sound it out, yeah.
Yeah, you just sound it out. Okay.
And I'll try to figure out what it's means.
Yeah, okay. And what happens to you?
Need a voice to thinking? Why not do it?
Yeah, okay, so this is that was really good. Actually, Jay McClellan, I did this talk, I used this, do people know who Jay McClellan is?
Yeah.
When he saw this slide, he was kind of going with the kind of like nativist perspective, and he actually has never seen this, but did try to do the voice because he thought he knew what it sounded like, and that was something that was worth taking. Okay, so for those who maybe are not getting it, you have this, when you do this kind of thing, you pair these words with like a very well-known character, or someone who has like a very particular line, which they often repeat, like good news, everybody, for people watching Futurama, or Homer saying dough. When you read this thing, you see the picture, and just automatically, the sound of that voice in your head is the sound of the character, okay? And so there's something about the association that you automatically bring to mind this kind of, what feels like to you, very rich perceptual detail that's much more specific than you would experience usually. Okay, so if you only remember one thing from my talk, only one thing, this is my theory of synesthesia. Okay, so, and more psychological kind of terms, synesthesia is a vivid and stereotyped recollection, a kind of automatically triggered mental imagery. And from my point of view, the fact that people with specific and automatically retrieved associations experience this as perception, it's not the thing that you're trying to explain, it is the explanation. It's kind of a lot of what synesthesia is about the internal evaluation of where those thoughts are coming from. What is that like? And they're evaluating those as visual, for example, with colors, they're evaluating them as visual phenomena. They're evaluating that way because they have a lot of rich perceptual details associated with them, and that they're generated automatically and that they don't have to do anything. It's kind of the feel of it that matters. Okay, so synesthesia is not just remembering, Ramachandran's like that, but it's still a kind of remembering. Okay. All right, so that's it for the philosophy part. Okay, now, this last question. How often do synesthetes learn their colors? And this work was totally made possible by David Eagleman. After we did the second paper with the 11 synesthetes, we emailed him, we said, can we look in your database to see how much learning is going on in it? And so he became a collaborator. This is a paper that's in review right now somewhere. And so this is kind of a cool figure. This is the color matching behavior for 6,500 synesthetes in his database. So all the rows are subjects, and all the columns are letters. And this is kind of especially if you're into synesthesia, this is kind of a cool figure, because this is a lot of people. Like the really big samples in synesthesia are like 100, and most samples are 10 or less, and many papers are about 1 or 2 people. And most of you will notice right away that there's a lot of regularity in the matching behavior, that A really likes to be red. And down here I've like written down like the modal choice for each one, and I've kind of made this color thing. And I'm going to refer to that as the modal matching behavior. I have some like scattered slides about the structure of this, which I'm happy to talk to you about people after, but I probably won't get to during the talk. And then one of the ways we can analyze the data is we can say, well, let's take each one of the RGB coordinates and turn it into a color label. One of the 11 Berlin K labels, say. And then we can plot these histograms, and these are actually distributions across colors for each letter, and then you can see that many of them have these very strong modes. So A really likes to be red, B likes to be blue, Y likes to be yellow, and so on. Okay? So that's interesting. That's like there's a whole talk in there somewhere. But I'm just gonna keep doing this part of the talk. So we don't know all the kind of sources that people might have for their letter color associations, but we do know about the one. And so the very first thing that we did is we said, well, let's make a little template of color labels that's exactly like the magnet set. So it goes red, orange, yellow, green, blue, purple, like that over and over again. And then what we're going to do is we're going to go through for every subject, we're going to count how many matches they have to the magnet set. That's 100% clear? Okay. And when we do that, we get a distribution like this. So there's log number of subjects on the y-axis, and then the number of matches to the magnet set. So you can see there's about 100 people who have 0 matches to the magnet set. And then you have this kind of peak around 3, and then this very long rightward tail. And so then the problem for us is, well, it's not a bimodal distribution or something like that, so we've got to define chance on this distribution. And some of you may be thinking, like, right away, why isn't this a bimodal distribution? And there's a good reason for that. Hopefully I'll get to it. And so the way that we did this, so we have to draw a line there somewhere and say, okay, the people on the right of that line are magnet synesthetes, or learn their colors from magnet sets, the people on the left didn't. And the way that we did this is we just shuffled the columns in the original data. So there are a lot of different null hypotheses you could have. One is you could say, I'm just drawing from like a uniform random distribution in every letter. If you do that, the expected number of matches on average is like 3. So anybody who has more than 5, the odds are astronomically low. But that's not a good reflection of the data, because the data itself actually has quite a lot of structure and it's not uniform and random. But what's nice about this as a null distribution is that shuffling the columns, so basically you're shuffling all the subjects A's and then all the B's and then all the C's and all the D's independently, is that it preserves the distribution of colors across each letter while breaking up the within subject contingencies. Okay? And also I want to say this is like the most conservative way you can do it. There are a bunch of other ways that you can do this that are less conservative, that give you more, but we thought this was a particularly good way. Okay. And so we make a histogram with the shuffled data, then we get this nice kind of unimodal distribution, and then we just said, okay, like around 10, you know, this is like all statistics. We just picked a threshold, and our threshold was our false positive rate is less than 1 in 1,000. And so everybody with more than 10 matches probably had the magnet set. Okay? And if we go back into the data and we pull out those subjects who form that rightward tail, and then we just plot their data, it looks like this. Which I also find incredibly convincing. I don't know. I don't feel like this needs statistics. It's just an eyeball test. You can see that it's there. But so this is like more than 400 people who all have their colors. And I want you to think back to this, both in terms of like the first graph I showed you, which is all the structure of the data in this, the notion that color matching behavior in synesthesia is idiosyncratic or random. And it's not like at all. It's incredibly structured. So one of the ways we did to check on this is that yes, I think I said this before, but I've spent part of my site career on thisoldtoy.com, which is a toy for Fisher-Price enthusiasts. And then it has little like serial numbers for each one of these magnet letters, and I can research where the toys were made and all this kind of stuff. It's really, I wonder how I got here. Okay, so this toy is manufactured between about 1972 and 1990, as far as I can figure out. And so what we can do is we can go back and we can look at the demographics of the data, and we can say, okay, when were the people born who were in the matches for the magnet set? And basically, this plot could use some improvement, but the red line, it's kind of a bootstrap 95% confidence, so we don't have to worry about that. But the red line is showing when the people who were born, who are in that group of 400 that I showed you. And they're kind of in like 5-year bins. And so basically, everybody in that group was born between 1965 and 1990. Which is good, because if they've been born all over the place, then we would have to worry about what we're doing. And then just as a comparison, because there's some more ideas about this, we looked at the number of people, so this is proportion of the whole sample in 5-year bins, okay? And so what I want you to think about is that between 1970 and 1985, for this 15-year period, right, basically 15% of the sample is learning their colors from the same stimulus, right? That's to me, is a very large number. And just for comparison, we also did it for the modal matching behavior. So the modal matching behavior, remember I said at the beginning, each letter was like, as you saw, in each column there's a very large structure. And you can say, okay, how many subjects had 10 or more matches to that over time? And it's 0 here in 1935 because there's only 8 people who were that old in the set. And then you can kind of see that even though it wiggles around, that whatever is driving the modal matching behavior is kind of a constant presence, like in the culture, and so it's driving the color matching. I hope that's convincing. Okay. So last thing. So one thing that you might say is, well, maybe these people who learn their synesthetic colors are not really synesthetes. They're like some other kind of thing. or there's two different kinds of synesthetes. There's the kind who learn, and then there's everybody else. And that seems reasonable, but I just want to show you some analysis of like the large-scale structure of the data that suggests that the real explanation is that all the synesthetes, color matching behavior, the magnet synesthetes and everybody else is driven by contingencies, most likely in the environment. And the difference between the magnet synesthetes and everybody else is that the magnet synesthetes have an extra set of contingencies, which is this magnet set. And the way that I'm going to show that is first by looking at, if you look at this in the top row, you can see those are the colors of the magnet set. And then the second row shows the modal choices that the population makes. And you can see that sometimes the modal choices in the magnet set just happen to agree, which is maybe an interesting thing and maybe not. Okay, but many of the group that were in the magnet set population don't have 26 matches to the magnets. They have less, they have 25 or 20 or 15 or 11. And so the question is, what is their matching behavior for all the letters, for all the times when they didn't match the magnet set? And what I'm showing is the most popular choice for each letter for all of those matches in the magnet group, right? So the bottom row is the 400 subjects who match the magnet. It's the most popular choice of color for each letter just when they're not actually matching the magnet. And if you compare the second row to the third row, you can see that they make the same choices as the rest of the population. That was clear? It's a lot of words. Okay. Here's just a couple other ways of showing you the same thing. The more likely you are, so on the y-axis here is the proportion of times for each letter, or the proportion of times for each letter that the magnet population, so those 400 people, how often they matched a letter to the modal choice in the population. So in this case, the way to fixate on it is y is yellow, probably because the word yellow starts with the letter y. How often did they make y yellow? And on the x-axis is how often did the rest of the population do it? And you can see that they're positively correlated, right? So that distribution that you saw on the first slide across colors is similar across these two groups, at least for the most popular choices. They're related to one another. And not only related to one another, you can flip it around and think about the other way, which is that they compete with one another. So the stronger or the more likely that you are to make a letter a particular color, so the more likely that a color, just think about it for a second. The greater the probability that a letter is matched to a single particular color. So for example, Y is very likely to be yellow again. The less likely that one of the subjects who has the magnets is to match that to the magnet set, right? So the magnet set is competing with these other influences, and the stronger the other influences are, the harder it is for them, at least empirically, as we observe from the data, the harder it is for them to learn that association. And then I'm just going to show you this last slide. Okay. All right, so maybe there's one thing that's still weird about this, which is that 15 years ago there were 0 examples. That's why this is so great. And now I have 400, and maybe that requires some kind of explanation, because it's definitely not because I'm some kind of super genius. And the answer is, first of all, that the internet allows us to find, the internet is like incredibly useful, so it allows us to do really huge samples, not only of synesthetes, but also of possible sources for things. And the second thing, and I actually think this is the most important thing, is that probably the mass production of the stimulus. So now there are like hundreds of companies that make these little colored magnets. Everyone has like a different scheme. But when Fisher-Price started doing this, they were like on the cutting edge of kids' toys, and they like owned the toy universe. So everyone, I meet so many people who had one of these things in the 70s. And so I think that's like part of our ability to do it. But one other thing is like, especially when I think about the Australian data set, is that if you have a small sample size and an uncertain source for color matches, it is very difficult to determine what is chance and what is not, right? So, if someone, for example, let's say someone had like a colored block that just had like 6 letters on it, and they learned 5 of them. And now you've got 26 letters and they've got 5 that match this thing. It's very difficult to evaluate that kind of evidence. So only in cases where there are exact matches will you really know. And then there's this other point, which is that subjects, even when they do learn stuff, tend to be a mixture of the modal behavior and also whatever the specific influences was. And so you get this kind of, you don't get 2 modes, you get this kind of like long skew. And so you're looking for people who are just a little bit different from the subjects around them, not out off in a different distribution. Okay. So I have like another 150 slides. But I actually did this, I got like 2 minutes to spare. I'm like pretty good with myself. Okay, so I just want to thank these people. Both Lara and County were advisors at different times. Both of them let me do this, even though this is what they don't do. And County may even think that I'm slightly ridiculous for doing this. Maybe Lara too. And then the other people all gave me useful content. Caitlin will be here in a couple of weeks. She's brilliant. And that's it. Thank you. You want to see a picture before you ask the questions? Can I just show one picture? I couldn't
Yeah,
we're
sure.
gonna put it in a talk, but it's like good. So just like before I showed you the meme, so the theory of my research comes from Reddit, which is a website where people do waste time in their research. And there's a synesthesia group on Reddit. Sometimes I look at it just to see not much happens, and every once in a while someone posts something that people get interested in. And people start posting their colors in it. And so I start looking through them. And this guy posted this set of colors, and I was like, oh my God, this is amazing. He's like another one. This is before we had the Eagleman database. And so you can send people a message. I said, oh, I'm a synesthesia researcher. You should really go to Eagleman's website and like do his thing and then let me have access to your data. So he did, and he sent it to me. And I was like, I just wrote this paper about the magnet sets, and your thing looks like exactly like it. It's like 24 matches. It's basically completely impossible that anything happened except you had a magnet set. And he said, oh, I did. And I was like, can you get me a picture of it? Because at that time I was obsessed with having a picture. And he said, yeah. So then he sent me a picture. And then the picture he sent me, he said, I'm sorry that it's a bad picture. That's what he sent in the email. And I'm going to show you the picture. The reason he thinks this is a bad picture is that this is very small and hard to see. But I don't care, right? The only way this picture would be better is if there were little wavy lines that went directly like he's there, he's like anyway, this is like,